Hi guys, in this video we're going to recap equilibrium constants. We'll then look at the link between Gibbs free energy and equilibrium constants, before finally looking at equilibrium position, equilibrium constants and temperature, and non-standard conditions before we summarise.
So in this video we're going to be talking about how the Gibbs free energy is related to the equilibrium constant, and we've got individual videos on both of these concepts. However, we're going to briefly recap what the equilibrium constant is, so you don't have to go away to remind yourself of that. The equilibrium constant is calculated by the equation given below for K. What it says is that we take the concentration of the products, so these square brackets mean concentration, and we raise these concentrations to the number of moles that there are in the reversible reaction equation. We then divide this through by the concentrations of the reactants, again raised to the power of how many moles there are in the equation. If the equilibrium lies very far to the right, then we're going to have a lot more products than reactants, and K is going to be a very large number. If the equilibrium lies a lot more to the left, then we're going to have a lot more reactants, so we're going to be dividing through by a big number, and K is going to be small, close to 0. So, now let's look at how that relates to the Gibbs free energy change. The equation we use to relate the Gibbs free energy change and the equilibrium constant is given here. Remember that delta, which is this triangular sign, means change, so delta G and then the standard sign means the standard change in Gibbs free energy. Now, for reactions that are feasible, you'll remember that the standard change in Gibbs free energy is negative. That's why we have a negative sign in this equation, because all the other components are positive numbers. Breaking these components down, we have R, which is the gas constant, given by 8.31. It has units of joules per Kelvin per mole, which makes sense because the temperature is going to have units of Kelvin, lnK is unitless, and the units of the standard change in Gibbs free energy is joules per mole. So as I've just said, the T stands for temperature, and this is given in Kelvin, and K is where the equilibrium constant comes in. We're taking the natural log ln of K, and K is the equilibrium constant. Now this is a useful setup of this equation if we want to calculate the change in Gibbs energy, because that's what we've got on the left hand side and we know how to calculate it, but we can rearrange the equation if we want to calculate the equilibrium constant.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today, and together let's make A-level chemistry a walk in the park.